In this episode, we're going to be looking at simplifying radicals. First, what is a radical? Well, anything written with the root sign is a radical. This sign itself is known as the radicand. And when you put something in there, the entire thing is known as a radical. So what we're going to do is look at today what happens when you have a radical that has something that is not a perfect square in it. So we will start off by looking at one that is a perfect square. We'll take the square root of 9. And this is a problem that should be pretty straightforward for you. You should be able to do this in your head. But I'm going to show you what's going on behind the scenes. When we're looking at this, we can take the 9, and we can actually figure out that the two factors of 9 that are prime numbers are 3 and 3, which means we can actually reimagine the square root of 9 as the square root of 3 squared. And when you take the square root of something that's being squared, the output from that is the thing that was being squared. So that's the stuff that goes on behind the scenes in a square root problem. What if we had something like the square root of 12? Well, 12 can be reimagined in a number of ways. One of those ways could be 3 times 4. 4 is a nice number. We'll look at it one more step further. What if we look at 4 as 2 times 2? So now we can reimagine that what we're seeing is the radicand of 3 times 2 times 2. Well, another way of writing 2 times 2 is 2 squared. One of the things we learned about radicals when we were working with them before is that if you have multiplication underneath a radical or division underneath the radical, you can actually split this up into 2 separate radicands, where each one has one of the factors in it, which allows us to look at this and say, all right, square root of 2 squared, I know that the square root of 2 squared is 2. Square root of 3, well, I can't really simplify that because there's nothing being squared inside, so I just leave that as the square root of 3. And so my fully simplified form of square root of 12, as I work through this problem then, is 2 times the square root of 3. We generally write the non-radicand number in front, kind of like when we write 2x. All right, so let's take a look at one more sample of that. What if we were taking the square root of 72? Now, a bunch of different ways to tackle this one, just like I said before. 72 you might recognize as 2 times 36. Now, at this point in simplifying a radical, we can actually, if we recognize that we have a perfect square, we can actually deal with that right here and think of this as the square root of 2 times 36, which is the square root of 2 times the square root of 36. Square root of 36 is 6. Square root of 2, nothing being squared underneath it, so we can't simplify that at all. And so we get 6 root 2. So that would be a quick way of simplifying this one. But let's take this one further. Let's keep breaking this down into its smaller parts. But sometimes we may not recognize we've got a perfect square in a problem. So 36, looking at that, that might be 3 times 12. Well, 3 is a prime number, so we're done with that one. But 12 is not a prime number, so we're going to keep going. Maybe we see that one as 3 times 4. Still not fully broken down. So 4 is 2 times 2. So what we're going to do is we're going to go back through all of those prime numbers, and we're going to rewrite this radical with all of those numbers. So there's a 2. I'm going to write these in numeric order. Times 2, times 2, times 3, times 3. I'm going to rewrite these, and what I want to remember is that as I'm doing this, since I'm taking a square root, I'm looking for squares underneath my radicand. So these first two 2's are really 2 squared. This 2 doesn't have a second 2 to partner with, so it just stays alone. Here we have 2 3's, so we can rewrite that as 3 squared. Now we have multiplication, so we can actually split that up into, we have 3 multipliers, 3 factors underneath there. So we can write 3 radicands and put each of our things inside its own radicand. Square root of 2 squared is 2. Square root of 2 can't be simplified because there's nothing squared underneath there. And the square root of 3 squared is 3. So now we're going to move the numbers that are outside the radicand together. 3 times 2 is 6. Square root of 2. And so that's a way to separate and do 72. Now it would also be possible to look at the square root of 72 in a slightly different way. We could look at 72 as being 8 times 9. Now this might be a good way of looking at it because we recognize that 9 is a perfect square. And so I could stop factoring out 9 and look at my 8, which is 2 times 4. Now 4 and 9 are both perfect squares, which means I'm at a really good place to rewrite this problem. It's 2 times 4 times 9. And then as I break that into its 3 unique radicals, square root of 2, square root of 4, and square root of 9. Square root of 2 can't be simplified. Square root of 4 is 2, square root of 9 is 3, and I get my 6 again. So now I have 6 root 2. We'll look at a few more examples of this in part 2.